Hey there guys, it is Saturday, that means second stream, and this is going to have to be more or less exactly an hour, so expect it to be only that because we've got D&D tonight. So 8:30 is when D&D start, give myself a few minutes leeway, just aim for an hour. So obviously we completed the other contest this morning. Basically, you know, it's one of those things, just got to put it together. And now we're looking at this one, and this is the one that I was talking about this morning that I really wanted to work on because I had a really good idea, and that's what we're here to talk about. So this is not a flash contest. This was one that was running for a full 30-ish days. I think it was technically like 28 or something like that. At least it was 28 when I first saw it. Regardless, point being is that this is the big contest. This is not a flash contest. This is a big contest, and that means that the prizes for it is a whole new printer or a whole bunch of filament, which is awesome, and potentially, even if we don't qualify, something else. So a very fun thing to go about. Now, I checked over the past week or so. I've scrolled through here looking to see if anybody else stole my design, and it doesn't look like anybody else did yet. One of the things I just keep on checking and hoping. But I just saw something that's pretty close to it, which was a little bit scary. Live on stream, finding out somebody else already beat me to it. But that so far does not appear to be the case. So what am I talking about? What is this big design? And the fact of the matter is just like their other contests. Let me scroll down here to the terms and conditions. You can submit any number of models, unique. Now, that is actually going to work out this time for me, because while I was working to get this prepped, I did some prep work on it this afternoon. I realized that there's actually multiple ways I can go about this, and therefore we'll be able to submit multiple models this time. Sorry if I'm starting a bit. One of those things, I'm Russian, so not the nationality. Anyway, what is the design? Actually, let's hop over to the camera. Good old camera. Start drawing. Notepad. All right. So how are we going to make this? Is it all going to be plastic? It's not all going to be plastic, and it's going to be a full-size table. Well, it's going to be full-sized furniture, I should say, multiple furnitures. And the base of it, because we're not going to print full-size furniture because that's crazy. Well, I'm sure there's YouTube channels that have. I've seen extruded beams, like actually extrude. If you go over to the One Army, shoot, what's the other name they go by? Basically the open source recycling guys. One Army, I can't remember the other stuff they go by. They've extruded beams before for using, you know, so they chop up a whole bunch of recycled plastic and then extrude it out into a beam, etc. I've also seen other guys do it, a pair of other guys that did it in their garage. They made plastic beams out of recycled PET bottles, PET bottles. Anyway, that stuff is cool. That's not what we're doing. Point being, my base material that I'm going to be using for this product is pallets. We're going to make pallet furniture with 3D printing. Now, I'm going to do 3 designs is what I'm thinking. First one is going to be a side table that just uses one pallet. Okay, so on the pallet you're going to have 3 of these pieces. The pallets I pulled out are 44 by 44. We can cut that in half and we can make a side table, and that will give us 6 pieces. So we'll have 6 pieces to use in here, and I've got a couple design ideas for how to make this side table with the 6 pieces. For the full size table, I think we go up to 2 pallets to give us extra 1x4s, or they're 1x4s ish. They're like one. Technically, it's one of those things. Wood size is right, so it measures 1 inch by 3.5, right? So that 3.5 is definitely a 4 by wood measurements. But the 1 inch, I guess, is 1.5 inches technically, 1.5 inches by 4. Regardless, we go up to 2 pallets for the full size table, and I'm thinking rather than having a center stand table like this one, we'll probably make brackets so you can, you know, just toss it on there and off you go. Now, the mechanism for holding the slats, we're going to use the slats as a tabletop, is going to be, I think, identical on both of these. We're going to use the same exact mounting technique for both of those. And then the third one, the third design, was... Oh, I was actually going to do a small standing table like this, but with 2 of these pallets so that these middle pieces are not half length. These middle pieces are full length. So you'll cut 2 of them in half for this, so that that's the same width as these guys, and then you just got to find another piece or 2 to make this full length here. So that's where we're at. That is the plan, and I have measurements. Again, I pulled my pallets out and got measurements for them, so let's get the measurements in here. And we will make some components. And I'm going to call this 1x4. Again, technically not 1x4, but and I'm going to this is one of those funny things, right? This is one of those funny things where all my material is in inches, is in imperial human units, but I normally print in computer metric units, so therefore I'm a little torn on which one to use. I guess we will be using the human units in this design, and then I will just manually insert metric units. Manually insert metric units is what I'm trying to get out of my mouth. Wood, pine. There's the 1x4, new component, small slats. So pallets have 2 different slats. They have small slats and large slats. Generally speaking, the small slats are the ones in the middle of the top, and then you have large slats at the ends of the top for more support. And then oftentimes, although it's not universal, I've seen small slats on the bottom. Oftentimes though, you also have large slats on the bottom as well. So the small slats, let's get that designed. Turn that guy off. These would be 1/2 inch, 0.5, and let's do this, get that set up. And then this guy, the small slat, was 3.5. Let me check my notes. Double check my notes. Notes. Small slat, yep, 3.5. Oh, actually the vertical I have down is 3.25, so I'll have to fix that. The interesting thing is that 3.25 doesn't make terribly much sense to me, but what do I know? And the pallets are square, so that will also be 44 inches. Now, while I'm setting all this stuff up, one thing I would like to mention is that, actually, come up here, don't make a child of that guy. One thing I would like to mention is that this design shouldn't be specific to my size of pallet. If you have a 36 by 36 pallet, etc., I want all the pieces to still fit. I still want them to work. The only thing that will change is that will obviously change your overall dimensions. So 1x5, that is the only change that happens if you use a pallet that is differently sized, is not the same size, which is convenient and useful. So I'm happy with it. 0.5, 5, and 44. And all these 44s probably should just be a pallet size attribute, but I'm not going to sweat it right now. So we have all our materials that we can build off of. So let's get to building. Actually, let us save this. And I will create a new, whoops, don't create a new folder, create a new project. Print tables. Come back here. Base features, I guess. And since this is, since I am going to use this as a base feature, I'm going to go ahead and make those things that I was just talking about. Palette size 44. Okay. Star that guy. Okay. And let's see. Save it. and then derive. That's what I'm looking for. Derive that, and we want to favorites and from components. Okay. And we can save this guy as side table. That's the one I want to work on first. The full size table, the square one that I was talking about, that one probably shouldn't be too difficult, and that one will be an easy one to start with. Dun dun dun. Yeah, now I'm sitting here thinking, why aren't I starting with it, right? Alright, let's go ahead and start with it. I take it back. We'll start with that one since that's the easy one and may as well get it out of the way. Okay. So, we are going to, very simply, yeah, this is what I'm going to do. I'm going to align the bottom here on this guy with the ground, the origin ground. And we can flip you vertically, okay. And then let us go ahead, capture position, and we are going to, not faces, components. We're going to go ahead and let us do that and that. And a total of 4, or no, actually a total of 2, right? 2 and 2. And I did all that work just to hit escape because I realized I was in inches. There we go. Capture position. Come back here to square. Swap that back to components. We're just building out some legs is all we're doing right here. For the record, if you did not catch on. 2 and 2 and pallet size. We don't have that saved. I'm just going to do 44 for right now. 44. Okay. And let us change parameters. Base features, users, pallet size, .ref. Again, this stuff should be namespace accessible in my opinion. I don't know why it's not. Then we will cop in here and change you. Ah, stop it. This is the problem when you hop back and forth between Excel and Fusion. One of them wants you to hit tab and the other one wants you to hit enter. Alright, there we go. So there's that. Again, very simply just going to do that. Now I'm going to pick this up, and the logical way is to continue with these guys. So what I'm going to do here, and we want to select component still, and I'm going to create a copy, and I'm going to rotate you 90 degrees, and then we will modify align, and I'm going to use these to span the bridge is what I'm doing here. Use that, spin that, okay. And actually it looks like what I should have done here, modify, change parameters. Actually, let's come into down here, 1x4. I called these 1x5s. These are not 1x5s. These are large slats. Whoopsies. Pallet size minus what am I looking for? Oh, 1x4. Yes. And we will star that. I forget. Can I rename this? No, I can't. Okay. And we will do D1 ref minus D1 ref. Actually, this one is not D1 ref. This is D2 ref. I think it's D2 ref. I could have these guys backwards, unfortunately. You're not going to let me start it? I guess not. What did I break? That's fascinating. Okay, okay, okay. There we go. Just fusion being fusion. Minus D2 ref. And hit OK and see whether or not that lines it up now. Modify, or if I got those two backwards, that would explain why it does not line up. And they are backwards, as it turns out. So, hop in here. You are now D2 ref, and you are now D1 ref. Okay, and modify align, unless I'm going crazy. There's always the distinct possibility I'm going crazy, but it does not look like it. It looks like I did in fact position that correctly. So we create another copy of this guy, create copy, drag them across. All these guys I probably should just have in a frame component. And actually, even better than being in a frame, I should have this only half. I should only have this half designed. I'm going to back up. I realized I just did all that, but I'm going to change this to 2x1. And then I'm going to delete all this stuff. Because rather than doing all this stuff and actually 1x2, rather than doing all this stuff and then having to fix it later on individually, that would be obnoxious. So we are not going to do that. Obviously that is some weird out in the way thing. I'm not concerned about it though, because we're just going to align this. Whoops. Not there, align there. And now rotate. There, and then flip. There we go. And capture position. So, the interesting thing, 1, 2, 3. Oh, there it is. 1x4x2. Now, the interesting question, because I don't normally do this, new component, frame, whether or not I can move those guys out. I mean, that guy should be able to move out. Okay, not support on derived entities. Fine. We can still use this frame object, though, to start building out the brackets here, the plastic brackets. So, let us turn that guy off. And actually, I'm going to really quick rename that guy to cross beam. And, okay. Fusion. So basically, when you copy and create and pattern stuff, unless you do paste do and stuff like that, and the boundary fills, you'll recall that I told you about boundary fills in another, in another video. Unless you do stuff like that, then it, keeps references to everything, which makes things obnoxious, unfortunately. So, and rather than that, I think I'm going to design this from the side. So we are going to just ignore those names because I don't feel like fixing that right now, because again, we only have an hour to get through this and we are about 20 minutes in. All right, technically it's 18, but I'm allowed to exaggerate. Turn the base features off. All right, so this cross beam, we can I'm just trying to think. My original idea, let's hop back over to the camera so that I can doodle my thoughts. My original idea for all these tops was, well, yeah, I mean, basically I was thinking of putting a bracket here, okay, to keep the slats from sliding off, is basically what it comes down to. And then slats, in here. The one thing I'm thinking right now is with 2 different slat sizes and wanting to be able to allow the end user, to mix and match 5s and 3s, or 5s and 4s technically speaking, 5.5s and 4s, however the heck the wood sizes work. In order to allow that, I was in this distance here, so if these are a bunch of 5s, they got to add up to 44, right? Because that's this cross piece, and technically a little under 44, because in theory, I'd have this plastic thing clipped onto the end. Although maybe not, well, yeah, it'd be clipped onto the end. Let's just leave it at that. Now, I could drill it in. So technically it would be 44. So 55 has to go into 44 evenly. Obviously that doesn't work. Or 5 has to go into 4 evenly. Doesn't work. 3 has to go into 4 evenly. Doesn't work. Neither of them work. We're always going to be over. So because we're always going to have extra space in here, I was planning on putting little spacers in here. That does a couple things. One, it provides a nice even spacing across the slats, gives you that little tiny gap in between. I wasn't going to do much. I was just going to do like maybe a 30mm shim or something like that to go between them. The trick there is that the user may not have the correct and actually I take this back. This isn't 44 on this guy. This is only 44 on this table here. Well, I'll redraw it because that's 44 there. But the other one, the side table, because we're cutting this in half, is 22. So because the side table is 22, I'll do the math for you again. 5 does not go into 22 evenly, and 3 does not go into 22 evenly. We still have the same problem. Point being, toss the shims in here. The shims plus the slats now are going to have to add up. So if we have, let's say, so obviously this can't be 10 slats. Let's call it 7, okay? So 7 slats times 3. We'd have to do times 3 if we add any 5s that are, technically speaking, okay? Let's see. If we do 5 times 3 is 15 plus 7, or plus 5, rather, gets us to 20, so that doesn't work. 6 times 3 is 18. 18 plus 5 is 23, so that doesn't work. I was just double checking if I couldn't come up with a quick combination of 5s and 3s. And technically these are 3s and a half, right? So my math is still off either way. In which case this guy might work. 5 times half an inch is 2.5 inches, and that gets us up to 22.5 inch. So actually pretty close with that one. Whoops, sorry, hit the microphone. Point being though, is that the amount of space that the user might have, however they end up switching these up, may not be what they have in shims for putting in between. That distance that they need to make up may be bigger or smaller. So just off the top of my head, what that does mean is that we can go ahead and we build these end clips here to hold the slats together. We can throw a screw in here and use that to take up the slack. So that's one idea there. And I don't know. I think we're all right. What did I come over here for? I mean, I came over here just to explain all that stuff for you. So I'm gonna look at the frame really quick. This is how our frame is. Whoops. Okay. There we go. This is how our frame is set up right now. This makes sense. Is there any, I mean, aside from turning this sideways to be vertically, I don't see any other, it doesn't make sense for these guys to go vertically, right? Because then they're center of that, and now that thing wants to teeter-totter. Technically speaking, we can use a plastic bracket, but it doesn't seem necessary to me. The slats are going to be going this direction, right? So anything our end clips that I'm talking about here are going to want to go on this direction, or have a raised section on this side at any rate. So I'm actually now thinking that maybe we come from this side then. So we'll back up. Control Z, Control Z, Control Z. And we'll toss the construction plane on this side. And draw on this side. So let's turn that guy back on just so that we can get a reference. And actually, I don't want that guy just yet, I don't think. So, because this guy, for this table I wanted, because it's so simple, I kind of wanted to do it without any hardware, so not screwing the plastic brackets to the wood, just having them sit there. And for that reason, I am going to actually move this guy after we're done here and design around it. So turn those guys off, turn that guy off. I'll leave these solid for right now, just because what we're gonna end up doing, I'm gonna toss this in here, that line in, and that actually let's not toss that line in there because I don't actually want it to be center. I just want it to be perpendicular. And that is going to be, I guess we're going to go with 5 millimeters, 6 millimeters. Just make it a little beefy, well, beefier. And let's go ahead and set that. Use a parameter wall thickness, just like I always do. This is going to be millimeters and 6. Okay. Wall thickness, and then we can do this wall thickness. Technically speaking, we could center this square on the any reason not to? I don't think there's any reason not to. So let us do that, and that's not gonna work, right? Yeah. What if I do this? Will that work? It technically does work, but that's not what I wanted. Okay. Let's Control Z and toss this guy there and center that. There we go. So there's that. I'm gonna toss this in here, I think. Go collinear with this. And whoops, that did not go collinear with that. There we go. And now we just need to constrain heights here. So let's see. I think 3 inches is probably reasonable. Not a science unit, very much a human unit, but that is alright. And then this guy is D1 ref. That's 1 inch, right? Yeah, alright. So D1 ref, so this gets us to the height of the board going across this way. Because, actually, yeah, because they're 1 inch thick. Yep, correct. And then, do I want it any higher? Yes, I do. I do want it higher because we also want to go ahead and put that screw mechanism that I said in here. So, that should probably be... I'm trying to think, because that's going to have to mesh with the, or not necessarily mesh, but the screw, whoops, man, hitting the mic multiple times today. That's not great. The slat going across here, so let me just draw the slat in here. This slat, 0.5, this screw is going to want to push this slat in. So I'm thinking this screw, you know, we can make it a 1/4 inch, I guess, 1/4 inch screw. And the screw is going to be want to be dead center of this. So if this is dead center of 0.5, so that's 0.5. So we want to add that, and then I really should go back and rename all these variables. The reason I didn't hop in here, change parameters, and do stuff like this, like large slat thickness. The reason I didn't do stuff like this is because last time I started naming variables inside of equations, inside of dimensions rather, sketch extrude dimensions is specifically where it happened to me. I did inside of extrude dimension. It broke. That was my biggest problem. So that's why I didn't do that this time. I guess we'll see if it breaks again. Yeah, may as well. Slat width 0.5. And that should be pallet size. Small slat. Small slat thickness. Small slat width. And you should be pallet size. And then the last guy. I'm just going to call this verticals. I'm going to call these guys vertical. Vertical thickness. Vertical width. And I said technically speaking I had these guys at 3.2, is that correct? Technically speaking. Yeah, I had this guy down at 3.25 technically speaking. Okay. And this guy over to pallet size. All right, there we go. Now all our variables, boy, have been updated, and this should be large slats. Save that and hop back over here, not the side table, over here. And let's take a quick look at this stuff, just make sure this stuff is still lined up. And it looks like it is. All right, cool. One of those things can break, so just wanted to check. Okay, now we can come in here, and this is the reason I wanted to do this, because D1 ref. Where's D1 ref? That's funny, that's still D1 ref. Vertical thickness ref. Right? Yeah, that should be correct. Okay. Just double checking that my brain's working correctly. Alright. So anyway, what we want to do, and it's one of these things. Also, the other thing that we could have optimized here is we could have had a slat component set within the slat component, slat thickness, and then use slat thickness in here. So large slat thickness would be slat thickness instead, because the slat thickness is the same for both of them. They're both 0.5. I'm just going to grab one of these for right now. Attempt to grab one of these for right now. Something is broken again. Let's hit OK. And then come back in. And try that again. There we go. Slat thickness. Alright, and now I can add that to this. So this is going to be vertical thickness plus slat thickness equals, and it is not working because it is obnoxious. That is why. Because Fusion. Why else? You recall how I said literally minutes ago that stuff was breaking, right? Last time we did this. So, stuff is now once again breaking. Alright, let's try that. Let's finish skets and see if anything broke outside the real world. No, nothing broke yet. Okay. Let's go back to the beginning and see if we can't make anything break, because Fusion is recalculating. Okay, nothing's broken yet. That's good. So let us delete this dimension, delete it, and then try it again. So vertical thickness, enter. All right, it does not recognize vertical thickness ref. Because. Thank you, Fusion. Alright, let's come down here, look at this stuff. Alright, yeah, I can't change these, so let's think. How are we going to fix this? Two options. We don't fix it, and we hack it. Those are our two options right now to get around this situation. So I'm just going to call this 1 plus 0.25. We're going to hack this and delete all this stuff because this stuff is currently unnecessary. I'm going to keep this circle in here. This circle is going to be centered between here. So let me do... Actually, will I draw this as 2? I think I will draw this as 2. So, whoops. Control Z. 1. I'm going to put this back exactly as I had it before, believe it or not. Although, you are not going to go there. Or I was hoping you were not going to go there, at any rate. Control Y. Okay, I'm dimensioning the wrong thing. That is why. There we go. That is one. And you now can come all the way up here. We'll make you guys construction lines. Have you collinear with that. You collinear with that. And this is now my 0.25, which is the slat mock-up. Collinear. And now we can go ahead and throw our midpoint in. And midpoint that. Alright, and this 0.25 is actually a 0.5. 0.5 is a slat size. There we go. Alright. We got there. It took a little bit of effort, but we got there. So, let's go ahead and extrude this out and create a thingy. But first, I want to create a... I could extrude it. Never mind. We're going to extrude it into a component. So all this stuff is just going to come straight back. Wall thickness. And we're going to extrude it into a new component. Do it that way. Leg bracket. Okay. And then we'll grab this sketch again and extrude out the rest of it. Minus vertical width divided by 2. So vertical width actually works, which is crazy. It is crazy that vertical width still works. Alright, I guess. We also want that guy. Okay, and then we will create mirror. Actually, that guy should be that guy, I believe. Whoops, wrong plane. That plane. Okay. And then we can extrude. That was a little bit of an obtuse way to go about extruding that, but you know, things happen. Yeah, that is just to that edge, so we want all of it. From object, that, and we want to go wall thickness, and that's going to want to be a minus. All right, there we go. So that just slides straight on there. Again, right now we're not adding any fasteners in there. And then we'll want to go ahead and add something here to tension this. One of those things, we have options. So we can put a capture nut in there. We could try putting threads directly into this socket and then having the, you know, putting a, including a plastic screw. That would stick with the theme of trying to avoid all hardware in creating this table. So I kind of like that idea. So let's go ahead and do that. We are going to probably thicken that out then in that case. Yeah, I'll just take that plane there. Project that. Whoops, what did I just project? I wanted that. And then we will give this some thickness. Alright, we got stuff in the way that it doesn't want me to select, so let's turn some stuff off. Turn that off, that off. Cool, cool, cool. Alright, and now we can go ahead and actually, you know what? I will go ahead and just tangent that. Keep things simple. And we will extrude that out from object. And let's make it an inch long. That's just an arbitrary inch long. Now, one thing I will say in terms of printing, right now, this thing really doesn't want to be printed. Let's see, how can we improve the problem here? And by improve the problem here, I mean solve the problem. Because the reason this doesn't want to be printed is that this is a whole lot of overhangs. So in other words, sorry, if we're printing in this orientation, then all of this is overhang. If we're printing on this back face, that is overhang there. And if we're printing on that face, this is overhang and the opposite side is overhang. Let me spin around like this. So if we're printing in this orientation, Not only is the inside overhang, but all this is overhang right here. And obviously if we print upside down, now you've got all this is overhang. Although, to be fair, you don't have this much overhang on this side. And basically, this is, I think, the last direction if we go face down like this. That has, the same problems as everything else, which is overhangs on the inside and that overhang on the outside. Hey, Wrath, thanks for joining in. Just seeing you now. Don't know how long you've been there. Sorry. So, because, let's see. What can we change here to improve printability? Well, first thing we can do is we can get rid of this top piece here. That doesn't necessarily solve all our problems. The other thing is that we could actually give up on the overhangs being problems and just say, well, the overhangs aren't going to be severe enough. This is only a 1-inch overhang. So if we say that's not going to be rough enough and we just compensate for it in the offsets, so just offset it a little bit more so that it has some space to hang, the threads to hang, that is probably alright. Probably not terrible. Other options. Well, other options would be actually modifying the inside here to add extra space for the overhang. That would be the other option. So offsetting in the top one. Overhangs are bad because the printer doesn't perfectly print, because the printer is not perfect when it prints, when it pulls the molten plastic across. I'm talking strictly 3D FDM printers right now. Strictly FDM printers. It's going to run plastic from one edge to another. It's going to stretch it like a string. That string obviously is not going to be perfectly flat. It's going to want to flex because it's molten. And even if you have really good cooling, you've got your cooling down really good, even then it still flexes a little bit, which means that it changes your inside contours. It gives a rough finish, which some people don't like. Now, this is going to be on the inside of this joint, and therefore you're never going to see it, so that's not too much of an issue. But what it will do is it will bring the ceiling down a little bit, which will mean that it's not sitting completely correct. Now, whether or not it matters that it's sitting completely correct is another issue altogether. It may not necessarily matter, which is kind of what I'm trying to figure out, whether or not I care right now. But it's always good to explore options to make sure you don't have overhangs. The other thing is, if I do say that this ceiling right here, if it's a little bit droopy and this thing is not sitting flush against the wood, that still doesn't change the fact that I have a big old overhang right here if I'm going to do this like I want to do. That, again, there's ways around that. So, for example, I can chamfer this out, or I can draft it out, any number of tools right here, just to demonstrate. Well, yeah, because this top edge is not going to want me to do it, so I would have to loft it, honestly. So, I could, solve the overhang issue here basically by, let me take a side profile, creating a slope right here instead, so that it's on a slope rather than simply overhanging in the abyss. That is an option. It's a way to fix this guy if I want to keep this guy here. But the question is again, how much of this is really necessary to be worrying about right now? Especially because, and don't believe you're here at the start, but I've got about 15-20 minutes left of this stream, and then I gotta go. So I want to get as much done as possible, so I think I'm going to leave this for right now and revisit this whole entire issue later and just get the whole entire thing mocked up. So let us turn everything back on, and let's go ahead and hop in frame and grab ourselves some midpoints, or at least a midpoint. Okay, so I can start mirroring. Whoops. Create mirror. And we will go ahead and mirror that component, leg bracket, cross there. That gets us 2. And then we will go ahead and create an offset plane, 44, minus pallet size. Okay. Oh, actually, not what I wanted to do. Minus pallet size, divide by 2 because we're mirroring. And then we will go ahead and mirror all these components. So that guy. Actually, let me align that guy first before we do this, just so I don't have to go back and do it again. And we'll hop up here to the main one, modify, align. Turn you off so I can see what I'm touching. There's that. You can go back on now. Okay. Alright, so now that's lined up. And now we can go ahead and mirror all that. Yep, capture position. And we are on components. So let's just do this. Drag all that. Make my life easier. And our mirror plane is this one that I just put in here. Cool. And now I'm going to go ahead and just toss some slats in here as a placeholder. And again, well, I mean, it's not even as a placeholder. It is just to get them out of the way, honestly. And actually, let me grab this edge instead. Grab that edge instead. Toss you up here. Okay, and then we are going to align that. Let's align this face. And we'll turn them off really quick so I can see. You want to be lined up against that face. Hit OK, hit capture position, whoops, Control Z, capture position rather. And let's go ahead and just pattern up across the path. That's the word I'm looking for. That path. And distance will be large slat. We don't have large slat width in here yet. It doesn't look like. Large slat width. Okay. And we'll turn the small slats off for now. Try that again. Pattern. Components. That guy. That path. Large slat width. And this should be, where is my spacing? There it is, spacing. Large slat width. And starting point 0. Huh. That is hilarious. Why are you doing that? Starting point 1. Yeah, hilarious. Okay. Let's do path direction. 0. Huh. Large slat width. I mean, this is supposed to be 5. Alright, there we go. There's 5. That's what I was looking for. There's 1. That's getting in the correct direction now. Alright, and then I wanted to add, the point being is I wanted to add the 3mm space for the 3mm shims. There we go. And now we fill it out. And I guess we're at 8 now. Okay, and then again. Goofed that one up. Alright. So back to this knob that I was talking about. This knob is on the wrong face. Which is a good thing I ran through all this, because now I know to fix it. Where are these planes? Where did I hide these planes? There we go. This is table mid-plane. Table mid-plane. And side mid-plane. Actually, that's... let's rename those. This one I'm going to call side because that has the vertical going across it. Side mid-plane, and this one I'll call middle table mid-plane. And then this guy was side of leg 1. Cool. Alright, now I know what these planes do. Now let's roll back here and fix this. Leg bracket. And And actually, we don't want to be here. We want to be frame. We actually want to delete this guy, and that guy will go onto the other face. So leg bracket. That's good. That's good. That's still good. Just double checking if there's anything I'm missing. I don't think so. This gap right here is kind of weird, but it's also not hurting anything, so I'm gonna go ahead and leave it. And yeah, we can just get rid of this guy now. And yeah, we can go ahead and delete that guy. We shouldn't be breaking anything. We can come back over here, toss this plane on this side, and toss that guy in over here. So we go here, go this down 0.5. Again, I'm using 0.5 because our whatchamacallits aren't working. Our variables aren't working from the other screen, unfortunately. The other file is not bringing them over. I don't know why. Alright, so there's that. And that gets us done, right? At least done for now. Let's go ahead and hop back out here. Yep. And again, the spacing here can be fixed if I wanted to. Question is, nah, I don't really want to make more than a 3mm gap in the boards. So one of those things again, the last board in here, maybe the last two boards in here, in a normal use case. And let's go ahead and just set that out, just for demonstration purposes. Let's go down to 7. In a normal use case, you would just substitute for smaller boards. Yeah, align, that's why I was in this menu. Align, and where's my small board? You go up here. And actually, let's not align you like that then. Let's align this corner like this to make our life easier. That corner over there. Okay, and then modify, align, bottom, top. Okay, capture position. And then I will just, rather than pattern, I should pattern anyway, just to keep everything similar. Whoops, that is the wrong button. Pattern, that guy. Select that guy. Spacing. Yeah, I mean, small slat wasn't working anyway, so we will just do this. 2. Start point 0. Okay. And I should add the 0.3, the 3mm in there. Plus 3mm. And then, like I was saying, the rest of this slack in here would just be taken up with these screws on the end, which we will model at another time. Again, goal was to get out of here at about 8:15, so I had an extra 15 minutes before D&D. So the fact that we're this close to being done this very simple build, again, this being the simplest one out of all of them, makes me very happy. Just doing a quick count here: 1, 2, 3, and then 1, 2, 3. So that's 3 verticals. So that is 2 pallets. That was what I budgeted for this build, was 2 pallets worth of material. And then we obviously have more than enough slats with 2 pallets to fulfill the top right here. So we are well within budget for this particular table. And honestly, I don't see much of a reason to make this any more complicated. The other tables, again, are going to be more complicated just because we're working with a smaller amount of pallets to work with. Just, you know, one of those things. Just a self-imposed limitation on those ones. So those ones will be more interesting and will take more time, but because they're more interesting, I expect them to be better looking. Well, I don't know, better looking, more aesthetically pleasing, I guess. More intellectually interesting. One of these terms. Figure out where this sketch is. Sketched. It should be in the leg bracket, right? I guess maybe it's not. Maybe it's in frame. I just see the sketch hanging out on the corner right there, and it's bugging me. There we go. So yeah, this table only needs a little bit more to get it finished, unless I think of something interesting to use, but I was trying to keep this as simple as possible. That way it's easy to build. So I don't know that will make it much more, if any, more complicated, this particular one. And then we move on to the other stuff, like I keep on repeating for the third time this stream. So anyway, have I filled my time to 8:15? No, haven't quite yet. Anyway, thank you guys for watching. Thanks, Wrath, for showing up. And I will catch you all later. Have a great and wonderful day, afternoon, or evening, wherever you're at in the world.